First of all, thank you for having me over, and always a pleasure to collaborate with you guys. Eh, as you're all pretty much aware, today we're going to be covering the power of LLM benchmarks and how to make use of them for your own purposes. A little bit about myself. My name is Jonathan Yarkoni. I come from a background in software engineering. Recently, I spent 6 years at Google leading AI and ML efforts in the region. In the past 6 months, I have my own consulting firm called Shujin. We take projects. Today's session is partially based on what I saw at Google working with customers and partially what we're seeing now taking projects. I would say that 80% of our projects are generative AI. More specifically, we're going to be talking about benchmarks today. Where do benchmarks come into play aside from following the news and seeing new models released every other day? When we work with customers, normally the first step they need to do or either have done on their own is prompt engineering. And at a certain stage, prompt engineering only goes so far. People who did it independently and measured it against, let's say, a business KPI. Let's say if it's improved their revenue, that's great. And where we come in is where they really want to improve the system. And for that, you have to have something that allows you to measure the system, which is more granular than just measuring whether conversion rate has improved or whether, I don't know, your bottom line has improved, which are great. Don't get me wrong. Like measuring those stuff and seeing an improvement is definitely what everybody should be doing. The second step is normally creating your own benchmark, and that's what we'll be discussing today. At a high level, these are the things we'll be going over. Fundamentals to make sure that everyone's on the same page. Then we'll discuss a bit about the challenges or why you need your own benchmark, in my opinion, from what we've seen with customers. And last but not least, we'll talk about how to personalize, how to make this your own within your company for your use case. I'll review a very simple yet relatable of how to create a benchmark for an email response use case. So let's dive in. What we'll learn today are two things. First of all, we will learn how to select the right model for your task. I'm sure all of you have been following the news and you know that there's Cohere and there's OpenAI and there's Google, and each have their models and they keep releasing new models over time. So first of all, there's the question of like, which one of those should I be using? The second is how to actually create your own benchmark internally after I've made the point of why you actually need one of those. So talking about the fundamentals, first of all, why should you benchmark? Aside from the reason, like my personal interpretation, which I mentioned a moment ago, there are many various different reasons that you should benchmark. That's how you identify strengths and weaknesses. That's how you eliminate things such as ethical concerns and bias. Sometimes for regulatory purposes, you must do it. But most of all, it's your only real way to be aware and continually improve the system. What do we evaluate? There are basically two things we can evaluate which correlate to what I said we'll learn before. There's evaluation of a model regardless of your use case, okay? Which normally is kept for like the foundational models. They're very kind of robust and they use the same data sets and they're pretty much well known, okay? You don't do this part on your own unless you work for a very large company such as Google, OpenAI, Anthropic, and so on. The second part is evaluating the system itself. Once you go and you selected a model and you have prompts and you have different use cases and maybe you've built some stuff out with LangChain, that is what we call the system. And that you definitely need to test. The model, just to put everyone on the same page, this is how a flow kind of looks from left to right. You have different prompts. You have maybe a prompt template. Those of you who have worked with either Llama Index or LangChain should be familiar with this part. Then you have the underlying model, and it creates a response. Model evaluation is when you select a model, and you can select various different ones, see the output, and take whichever is fitting for you. We'll go into better ways to select a model in a few. in the past, or when you were doing NLP a few years ago, we had some benchmarks or tests. Some of you may be familiar with things like Rouge, Blue, and Glue. Some of these have also been adapted to better fit the new LLM use case. But since now the models are, for lack of a better word, fundamentally different, and they're fundamentally different in two main ways. First of all, they're better able to reason. And second of all, they have a much higher fluency. And things such as, if to give a very basic one, which does not appear here, such as WER, which is word error rate, they simply do not capture these emergent capabilities of the new models. And those emergent capabilities are exactly what you're making use if you are using LLMs for your use case in production. So given that these are not as good as they used to be, what are some that are? There are a lot of new benchmarks. This is by no means an exhaustive list. I just wanted to kind of segue you into being able to navigate this new landscape of benchmarks. We'll review a couple of them. I listed here six, which I think are interesting. So first of all, we have HellSwag. This one evaluates common sense. Truthful QA, as the name implies, evaluates truthfulness. MMLU is a multitask benchmark. So it tries to see how well the same model is able to perform different tasks. Drop is an English reading comprehension. ARC is for reasoning. And MMU, I think, is an interesting one because this landscape is also continually evolving. And as the models exhibit new behaviors and as people figure out new ways to evaluate them, new benchmarks are created. MMMU is aimed at multimodality. If anybody has been following the field, they know that multimodality is all the rage now, with OpenAI having GPT-4V and Google recently releasing Gemini Pro and announcing Gemini Ultra. So MMMU is a recent addition to these benchmarks, which aims to evaluate multimodality capabilities. Let's dive a bit deeper into what is behind these benchmarks. So again, going from top left to bottom right, HellSwag is a data set of 70,000 sentence completions. We'll see examples of each one of these in a moment, in a couple of slides. Truthful QA is a data set of relatively not a lot of questions, but that span 38 categories. We'll see an example of that. MMU, again, 15,000 questions. They're not all exactly the same. ARC is 14 million and MMU is 11,500 questions. I show this so that you're familiar. Obviously, you're not going to be wanting to run the ARC by yourself because it's 14 million questions and it's probably going to cost you more than a dime. But Truthful QA, you might be inspired, take it, do something with it. Next, on each one of those, you can see that some of them have 10 shot or 6 shot, 5 shot, 25 shot. What does that mean? When we work with the models and we're prompting them in order to get a response. Specifically, if we're testing the benchmarks, we want to get a very specific response or a very specific set of responses. Sometimes some of these, such as HellSwag, have a few different right answers. MMLU and ARC do not. They're an ABCD, so they only have one right answer. The shot or the number of shot is making use of a very powerful technique that was, it's a paper, I think, by DeepMind, Google, where they figured out that if you give a model examples of similar questions and also how to solve those questions, it's actually able to do what's called in-context learning and better able to answer the questions. And this is very critical. The more shots you have, the better the model performs. It's a research field, and some of these do actually have what's called zero shot when no examples are given. But normally speaking, the more shots you have, the better it is. Now, I wanted to kind of segue a bit and give you a real example of how much this matters. Anybody who's been following, late last month, Google released Gemini with some allegedly very impressive results. So here you can see on the MMLU that we saw before, they claim to have surpassed human experts to 90%. The paper actually benchmarked it on various different, even this is not all of the benchmarks that were used. These are specifically the first batch. And you can see that I think it was 12 out of the 14th, Gemini had, at least Gemini Ultra had surpassed GPT-4. And yet Google got quite a bit of backlash for this. Why did they get backlash? So first of all, HellSwag, which is common sense, they did not beat GPT-4. There's actually quite a gap there of almost 7 point something percent. Common sense or sentence completion, which tries to measure common sense, it also translates into how human-like the conversation feels. So you shouldn't just take these at face value and say, oh, I need more common sense in my use case, or I need a better common sensing model. You need to understand what each of these aims to measure, despite of how it might be measuring. MMLU, the multitasking, which is the graph that you saw before, Google in the videos kind of reported the 90.4, and GPT reported the 86.4, which to some respect is very much cherry picking. Why do I say it's cherry picking? When GPT-4 first tested its model, which was earlier in 2023, they did a 5-shot. When Google did the 5-shot, as you can see in yellow, and as is reported in the original Gemini paper, they didn't beat the GPT-4. They got 83.7, which is less than 86.4. However, when they changed to a chain of thought with 32 examples, they beat GPT-4. You can see that they tested it also on their own with chain of thought and 32 examples. And there the comparison was 90.04 to 87.29. And so that was a bit of backlash that Google received. And also I was trying to make the point of why the number of shots really matter. It's not the only thing that matters when you're benchmarking a model. We'll see some in a little bit. Going back to the benchmarks, and here I just wanted to show you again how some of these questions from the data set actually look. So you can see that in HellSwag, it's simply like a sentence completion. It leaves it open, the model completes, and it has a set of possible completions which the model deems as correct. Truthful QA it takes from the internet, and that's also why the data set is not probably as big. It takes things which are known fallacies and kind of wants to see if the model kind of imitates the human known fallacies, such as like, where did fortune cookies originate? I assume that most of you know, and some of you might remember childhood being told that, fortune cookies are not actually from China and that they were invented in the States. MMLU, one question as an example, an important source of credit information rating of retail businesses is, then there's an A, B, C, D. Obviously here the answer is the FICO score. It will have tasks from different disciplines. This is just one example of finance. Drop, I remind you, is the reading comprehension. I'll read this one out because I think it's quite interesting. In 1517, the 17-year-old king sailed to Castile. There his Flemish court, so on and so forth. In May 1518, Charles traveled to Barcelona in Aragon. Where did Charles travel first, Castile or Barcelona? Now, this one is interesting because first of all, it has to figure out that, on the first case, the 17-year-old king is referring to Charles, and it has to figure out that he traveled to two places and that one of them occurred prior to the other one. Obviously, the answer is Castile, because that's where he traveled to first. It not always so easy to do. Think of what grade you'd have to be as a child or as a student in order to kind of reach that level. ARC is to do with reasoning. Similar to MMLU, it also has an ABCD. George wants to warm his hands quickly by rubbing them. Which skin surface will produce the most heat? The right answer is dry hands. The wrong answer are things like wet hands and so on and so forth. MMMU is aimed at multimodality. Here you can just see a question from art and design. There are several different fields from which you get questions from. I think it's 6 different ones. None of you will probably know, but like I played piano as an adult for 2.5 years, and I do not know the answer to this question. And this is only the medium difficulty, meaning there's also a hard difficulty, and it also pertains to a wider range than just art and design. Great. As I mentioned, you don't have to go and benchmark these on your own. There are known leaderboards which invested the time of setting it up, which continuously benchmark the different models. Some of them are listed here. Hugging Face is very good. It has a lot of different models. It continually re-benchmarks the different models. Helm takes a more holistic approach, checking other things such as accuracy, other metrics such as calibration, bias, toxicity, and so on. LMSys is one that I chose because I find it very interesting. They implemented a sort of ELO rating similar to chess, where if you win a game, you get some points, and if you lose a game, you lose some points. Here you chat with the model, and each time you're presented 2 different answers. Out of these 2 different answers, you get to choose which was better. And that's the model that gets the points. And the other one is the model that loses the points. So very kind of nice way to blind test which model is better. Great. We are getting to the second part, which is challenges and process. So what are some of the challenges in benchmarking? Again, I won't go over the whole list because we won't finish this lecture in the hour, but I'll just mention a few of them. So first of all, benchmarking takes a lot of time and money. You have to set it up. You have to set it up correctly. There's a paper which I mentioned in 2 slides from here that showcases that just putting another space in between question changes the result. And obviously, things such as, let's say you're asking it to predict the right answer from A, B, C, D. If you're just taking the highest likelihood, like the logit, like the percent, whether the next predicted word is like A or B or C or D, it might get a certain performance, but if you look a few tokens in, it might change the answer for better or for worse. And perplexity, there's simply like an over-reliance on it. Variability of models. They're always changing. There are always new models. If anybody's been using OpenAI for the last year, OpenAI got quite a bit of slack that they were changing the model under the hood. How do you benchmark? A lot of times we use human as labeling, and even humans aren't always perfect. There's leakage, data is limited at the end of the day, and there's simply like degradation of some of the models with fine-tuning and techniques like that. And there's also like a difference in chat syntax. To name just a few, or kind of prove the point of a few, you can see here the 2 different models like Vicuna and Falcon LLM. Technically, they should be exactly the same. They're fundamental models of similar sizes, and yet they were trained very differently. You can see kind of the syntax that was used when they were trained. And this can affect the model at the end of the day prefers to see the syntax which it was trained on. And if you give it a syntax it was trained on, it tends to understand what you mean better than if you give it not the format that it was trained on. And second, this one is again on the evaluation of the MMLU leaderboard, a very nice write-up on Hugging Face, which shows how easily by changing very small things, you can actually change the performance of the model. Okay, you can see here that on the different benchmarks, it kind of the same models gets different rankings. Just if we go on like the Llama 65 billion, once it will get first place, and then second place for the MMLU. All of this was to make the point that initially you should select the right model for your use case. If you need a model that is better at common sense, then definitely go check out the HellSwag and see who's leading there. If you need a model that can better do reading comprehensions, then you should take the drop. If it's not exactly one of the tasks that they're directly measured by the benchmark, you should figure out what kind of indirectly correlates with the task you're trying to solve. Now, once you have selected your model, you're obviously going to go on to develop your use case, which again, there's the LLM model evaluation. That was kind of the first section. And then there's the system evaluation. Now, okay, once you have decided the model, you can kind of verify it on your own test case. You can see what the benchmark itself uses. They're all widely available, which is kind of why they have the challenge of leakage and stuff like that. And you can go and kind of see on your own, try to see how well a model that you're choosing benchmarks. I don't recommend doing this on your own. Again, I recommend already using the widely available data sets. Very rarely will you ever have to kind of do this part of choosing a model on your own based on the known data sets. Once you've selected the model, there's a second part of actually testing your use case, which normally means testing things such as specific prompts and specific prompt templates. In this section, the model stays static and the rest changes and is evaluated as it changes. There are two testing strategies. You can use humans, which is manually, or you can use a different model in order to both generate and also evaluate. Some people might think to themselves, well, humans are great and humans are good. Humans are also expensive. Humans are slow, and they don't scale well. Meaning you can't really create with humans 5 million examples and test them. With a model, you could. And some people will say, but how can you use a model in order to evaluate a different model? To which I'll say a couple of things. First of all, we use human intelligence in order to gauge or measure human intelligence. So that's kind of food for thought. And second of all, perception is easier than generation. Okay, when you're trying to generate an answer, you have to balance out a lot of things. You have to balance out how long it should be, what it should incorporate, remove things such as bias and toxicity, and getting the answer actually right. So the model, when it's generating the answer, has to balance all of these things and more. But when you're trying to measure something, when you're measuring a property or a metric, such as, let's say, the length or the toxicity or the bias, it kind of has to focus on one thing. And the models are able to do that. And that's why, in my opinion, it works very well. At the end of the day, the right answer is somewhere in between. It's partially humans and partially model, because model isn't always as good as a human, and a human isn't always perfect. And kind of amalgamating the two is probably the best approach. And some trade-offs when using model testing, which is what I'm a big proponent of. It's cheaper, it's faster, you can reach higher granularity, and you can dive into things which I don't say now, such as token probability, and some more things, some bad things. It really suffers from bad prompts. And if you have a bias in the model which you're using to measure, you're kind of going to continue that bias into your current system. How do we build our own benchmarking system? So by this point, I hope I kind of it helped you realize how to select your own model, and also kind of convinced you that once you go and create your own use case, you should be building your own benchmarking system in order to be able to evaluate, in order to be able to improve. I want to kind of go over a scenario here so that you have something relatable, and so that in hopes that you better understand what I mean by benchmarking your system. So there are 4 steps to benchmarking your system. And let's just take a hypothetical scenario. You want to create a use case that automatically responds to business emails. The first step, which we've previously done, is to choose the model that you're going to be using. Let's say that I wanted to have a model that sounds very human-like. I should have known that I want to go to HellSwag. And let's assume that at the time of the writing of this deck, Llama was the highest model on the HellSwag. So I chose that one. Next, I have to choose a metric. For our purposes, let's say that I'm choosing relevancy. Next, I have to create a benchmark, kind of a golden data set, okay, for which I know the answer to what I'm trying to check. And last but not least, I have to evaluate the benchmark for the metric, or basically run the metric against my golden data set. For that, again, I can use either GPT-4 or a very powerful model. Currently, the strongest model out there is GPT-4. And when we do these with customers, we recommend that you use GPT-4 and or humans. Okay. GPT-4, again, it's an automated way and it scales very well. And it's always good to kind of cherry pick a few examples with humans. There are a lot of different metrics that you can choose. By no means is this a comprehensive list. I listed here a few. 2 things I'll mention on the slide. First of all, we're going to be testing for toxicity in the use case. And second, you can define an LLM defined metric, which I find very interesting. And there are some frameworks supporting this. If this is beyond the scope of this lecture, but there's RAG systems, and to evaluate RAG system, there are things such as RAGAS, which is a framework for evaluating RAG systems. And in RAGAS, we have things such as aspect ratio, which basically allows you to define a metric based on an LLM. So you can tell the LLM stuff such as like, tell me if this is appropriate for children. And then it will go and check. Beyond the scope of this talk, but I really recommend that you check it out. Very interesting. And I think we're going to see a lot more emphasis on LLMs kind of defining the metric. Back to our use case. So we need to go ahead and create our golden data set. So either we generate the emails from scratch or we find a database online. This can be done using any model or already having a data set from somewhere else. Then we have to generate a response to those mails, which is what we're trying to do. This time we already have to use the model that we want to use. Okay. And here you see I've chosen the Llama model, and I'm going creating a response to all of these emails. The third step would be running the evaluation. Here I am trying to evaluate the metric of my choice, which is toxicity. So I'll just run it. Again, I can use a very powerful model, or I can use humans, or I can use a combination of the two. Those of you who are kind of reading what's in the table, you'll see that two of the answers here have a very high toxicity, which is not good, not something that I actually want. What can I do? I can go and I can change the prompts. And once I've changed the prompt for generating the response, you see that now only one out of the three is still at high toxicity. And here I might go and change the prompts again, or alternatively, I can go and change the model. And now you see that for the three examples, I have low toxicity on them all. Um, Obviously, I can and should evaluate many more metrics than just toxicity. It depends on your use case. Also, the level depends on your use case, what you're willing to suffer. Normally, when it's an external facing system, you care much more about things such as bias or toxicity, or stuff such as hallucinations, which I haven't touched upon, but there's also ways to measure relevancy and faithfulness and factuality to kind of negate hallucinations. Um, and that's kind of it. There are a lot of tools which will help you do what I've shown much, much faster. I just wanted to make the point of like why you need to do this and how you need to do this. Again, this is not a comprehensive list. I could really recommend that you look at some of these, such as deep checks and ragas, which I mentioned. I thank you all for joining us today. I hope that you've learned something. If you have, feel free to share this recording with anybody who might benefit from it as well. Thank you all for joining. My name is Jonathan. If anybody wants to shoot me a mail about a business inquiry or a question, feel free. This is also my Twitter handle, where I release kind of things that we're seeing with customers and different benchmarks that we run, or new and relevant news releases that we find. And I thank you all for coming. Have a great day. If anybody kind of has questions, I'll be happy to spend a few minutes trying to answer those. So I'm just going to go over the chat and kind of start answering from there. So Sven asks, is there a way to know how a model was trained so your prompts can be more accurate, aligned, getting better outcomes? So the answer to that is yes. The open source. So first of all, there's a lot that goes into knowing how a model was trained. Most of the models kind of tell you how they're trained. OpenAI says to some extent how the model was trained. It really is beneficial to see how the data set was structured and some other things. Those are normally going to be more widely available for the open source models. Where I don't know that there's exactly like one spot, I normally start from Hugging Face. Is there a way to measure leakage in the popular benchmarks over time? And is there a way to compensate for it? So that is a great question. I don't know that there's any benchmark that measures leakage. Yes, there's a way to figure out if a model was kind of using a certain data set when it was trained on, because sometimes you can make it regurgitate. If anybody's been following like the OpenAI versus New York Times, and they've released a couple of articles on it, and they've called this phenomenon kind of regurgitation, where the model is able to reproduce an example that was trained on. It's easier to see with image generation models, because it's rather easy to see that the same picture has been kind of regurgitated. It's a problem. I'll kind of make the case why it's a problem. The data sets are known, and the data sets are on the internet, and the data sets have also sometimes been curated by widely available material. If I'm just talking about the ARC is 14 million questions, which were curated from college books and things like that. So first of all, you might have encountered those college books unintentionally, not trying to copy the questions from the data set itself, but they're probably circulating on the internet. And second of all, some of these things or other questions might just be very, very similar derivatives of the actual data set. So that might be a second problem. Are these methods good at evaluating creative content such as novels? And so great question. To some extent, yes. Have I seen a use case for this? Not yet. I would argue that probably the best way to do this would be to use models in order to evaluate. So creating like your own metric from a model, similar to what I explained about like creating an aspect ratio using RAGAS for like, is this content appropriate for children? And you'd probably have to think of a more robust question than, is this creative writing? Because I imagine a lot of writing falls under the category of creative writing. Next question: how do you determine the amount of data to use for benchmarking for a custom application so as to guarantee diversity and take into account the cost of custom data generation? That's great. It's kind of in the question that you ask. The rule of thumb is to have it diverse enough, and you have to see that your distribution is well satisfied and that you have enough examples for every different thing that you might encounter and whatever you're trying to measure. The thing is, you can get by with very little examples. So it's relatively easy to start and slowly scale as you're going. It's not a one-time thing and then it's over. And you also don't have to start from the end. You don't have to start from evaluating 5 million examples. Start small, you'll realize the cost. A lot of times the cost is linear. So if you have 10 examples, it costs whatever, $1, which it doesn't, but let's say it does. And if you have 10 times, normally costs 10 times the amount of dollars. And so it's very linear. So I'd start small and progress from there. Great. And there seem to be no more questions in the chat. Thank you all for joining. If anybody wants to get in touch with us, feel free to use this email or follow my Twitter, where I advertise a lot of relevant content. Thank you very much. Have a great rest of the day.
Thank you, Jonathan.
Thank you.